Yes! No, 8 times 10 times 10 times 10. This is good. This is turning into a good arithmetic lesson. Hang on.
Ours is 8 times 16 times.
Yes, yours is 8 times 6. Yeah, you guys are doing different ones.
Times 16 times 16. Cube, you gotta do it 3 times.
That is the number I've got.
There's some great questions coming up. There's some great, I think, arithmetic questions coming up that I think we should answer right now while we're here. I mean, it makes a lot of sense to talk about this. So we're going to do the estimates, the estimated volumes. Okay, the questions are, how do we deal with 8x cubed when we're substituting the values of x in, of 10 or 12 or 16? How do we deal with that 8x cubed? So low, medium, and high. Okay, so low, 8 times 10 cubed. Okay, that's what you guys have to do. You have to take the x out, put a 10 in, and go from there, yes? X out, 10 in, go from there.
But where did the 10 come from?
The low ball estimate, you're using the 10.
us.
Oh, you guys are going to use 16. That's what we're going to do 3 of them. We're going to do 3 of them here, Doc. So we're going to do 8 times 12 cubed, and we're also going to do 8 times 16 cubed. So it depends on which rows you're in. You'll do one of each of those. But the mathematics is what I'm going to pick on right now because that's what I think is giving people agita, giving them like stomach cramps and lower back pain. What gets cubed? Even if you didn't see parentheses. Even if you didn't see parentheses and all you saw was that. Why just the 10? Tell me your name again.
Nick.
Nick, thank you.
It's because the 3, the cubed is attached to the 10 only.
And what makes that happen before 8 times 10?
Order of operations.
Because that's how our mathematical system is set up. That's the same reason when you put the water with the cement, you get concrete. You just put the sandy stuff and it turns into concrete because that's how it's set up. That's how it sets up and how it's set up. We have set up our system to do this. When you write it like this, it means multiply, 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 and then take care of this guy. So that becomes 8 times 1,000, which is 8,000 beats. That's our low ball estimate. Good. What's our medium estimate? I think that's it right there, right? 13,824?
Yes.
Which seems unnecessarily exact, but whatever. 824. It seems a little bit silly to say it down to 24, but whatever, it's totally fine. And with 16, well, because everything's an estimate. I mean, to get it down, it's like when they tell me Mount Jefferson is, I just saw this at the top of Mackenzie Pass, there's this great sundial thing, and it points out radially to all the mountain peaks and tells you their heights. 10,495. No! It cannot be. First of all, it's a Cascade Mountain because it's eroding as we sit here and talk to each other. And the fact that we're down to the nearest foot is just ludicrous anyway. Anyway, how about times 60? What did you guys get? 32,768. There we go. Now here's the deal. Which one do we believe? Which one do we believe? I heard, hold that thought. Hold the answer to that question I just asked and reevaluate. Because you're all looking pretty panicked right now. Let's do a lower one where we use 9 across the bottom. 9 cubed. Okay?
Are you going to go through that and tell us?
To go through what?
Are you actually going to tell us how many beads are in there?
If I counted it myself, I would.
You didn't count them?
But I didn't. 5,000, oh God, are you kidding me? This is why we use estimation, I don't have to count. and I bought the beads in little bags at the dollar store, so they didn't tell me how many were in there. They said made in China, here you go, I bought a bunch of beads. 5,832. Look at the difference in these results when we're off by 1 bead. Why is it so exaggerated when we're off by 1 bead? Off from 9 to 10, 10 to 12. Why are there such very vast differences? Say that again?
It's the power of 3.
It's to the, tell me your name.
Joe.
Joe, that's right, because it's cubed. That estimate is being cubed, which is being used 3 times. So think about it, you're multiplying it by itself. If it was a fraction, it would be shrinking in the same way, but since it's a whole number, it's actually growing in that way. That's one of the problems with estimation, is that you have to get somewhat of a reliable estimate with something you're using that many times. Keep that in the back of your mind. Keep that in the back of your mind. That's what I'm going to come back to. That's what I'm going to come back to. Yeah? Yeah? Jordan, what's up?
Oh, like our estimates before we did all this were super
Super, well, and you guys gave me 1250 and 3, whatever you, how are you guys doing that? Was that just like a shoot from the hip? Like, 12. Is it pretty much?
Pretty much.
Totally fine, Micah, yeah? Totally fine. Totally fine. But you see what happened? We underestimated. I trust your guys' approximations here. I trust them. I trust them. I'm not so sure that we should go with the super highest one, especially because it was an outlier by the data set. I'm not trying to pick on whoever said 16. I'm not picking. But I'm saying that since that was such an unusual data point, maybe that high was a little bit silly to say. Maybe if you wanted to actually get a high estimate, maybe use the 13 as the highest point and say it's somewhere between, say, 8,000 and whatever that would be, 15,000. And that's an estimate, friends. That's an estimate. It gets us pretty far away from what we originally thought, doesn't it? Isn't that wild? Isn't that wild?
Yeah. Yes.
Okay, you're getting that glazed look. So it's time to kick you out of here. But this is going to be a work break. Here's what I want you to do. I'm going to kick you out of the room. I want you to leave the room. I do. Not because I want to get rid of you. I want you to come back too. Hang on 1 second. I'm going to find something here for you. Maps. Does anybody have a cell phone with them? They can, well, actually, most of you probably have cell phones with you, right? So if you have a cell phone with you, does it have a stopwatch on it that you know how to use? If it does, that'll come in handy. If it doesn't, let me see this. Did I type maps? There we go. Let's go with Ben Camp's map. If it doesn't have a stopwatch, that's okay. We'll just go to the nearest minute. Here's what I want you to do right now. I want 2 numbers from you guys. We're here, right? Perfect. I want 2 numbers from you guys. We are at Grandview Hall. I want you to estimate how long it will take you to walk from Grandview Hall down the main front path, which you have to go out that way. Don't start timing until you get to the front doors. Get out to the, what are they, west-facing doors? Is this west? I think it is. Yeah. So go out to the west-facing doors, and then walk at a casual gait, down the main path, go by Modoc, take a left, right, take a right, and then go to whatever this would be, whatever this door will be at Metolius. Well, that's Metolius building, I don't know what direction it is. The right side, as you're looking at the right side. Take a leisurely gait, walk down there. Estimate how long it would take you to walk that. Estimate how long it would take you to walk that distance, okay? And then I want you to go do it and time yourselves. So I want you to come back here after the break with 2 numbers. Number 1, your estimate that you can figure out right now. How long do you think it would take you to walk, make this bigger so you can actually see it, just walking comfortably from Grandview to Metolius. Okay, you see the path you're going to take? Downstairs, you're into the quad, Modoc's on your right. Walk past Modoc, down that set of stairs right there, and then kind of bear off to the right, glancing right. There's a pole in the middle, stay on the right side of the road, we're not in England. And then eventually, the next left, the building right there is Metolius. Walk up there, touch the door. That's a one-way trip. I wonder how long it would take you to do a one-way trip from Grandview to Metolius. Estimate first.
So you're gonna make us freeze.
It's like summer out there today. I was sweating my butt off riding to work. If you need a stopwatch, I brought some of those too. So if you don't have a cell phone or a timekeeping device, I brought stopwatches. So take 5, get some water, get some air, write down an estimate, and then go time yourself. Yes? Yes.
Take us old people a lot longer.
That's okay.